Now that we know about significant digits and we know how to figure out how many significant digits a number has, let's look at how we can use that when we're doing math. When we are doing math, we want to make sure that our answer has the right number of significant digits, especially when we're doing math in science class. Okay, so most of the time, the formulas that we use require you to multiply or divide two numbers. So we're going to focus on the rules for how to figure out how many significant digits your answer should have when we're multiplying and dividing. The first thing that we do is we look at the numbers in our problem. Okay? We look at each number that we're given in our problem and we count the significant digits in each of those. Right? Once we know how many significant digits each of those has, we know how to round our answer, because our answer should always have the same number of significant digits as the number from our problem with the fewest significant digits. Most of the time, that means we're going to need to round our answer. When we round it, we're going to round the answer so that it has the same number of digits, significant digits, as the smallest answer from this count. Okay? Let's look at some examples, because I think it's clearer when we look at examples than it is when we're talking about it in theory. Okay, so if we have something like 16 times 4, if we just pop that into the calculator will tell us that our answer is 64. However, in science class, we're going to want to make sure that our answer has the right number of significant digits. So let's count how many significant digits each one has. 16 has 2 non-zero numbers, so it's got 2 significant digits. 4 has only 1 digit and it's a non-zero, so it has 1 significant digit. That means that I can only have 1 significant digit in my answer. Okay, so I'm going to start all the way from the left, and I'm going to start counting from the left. 1. So this is the place value to which I will round. I'm not going to drop the 4 off, because that would change 64 into 6, and that's not rounding. 6 is nowhere close to 64. I've got to leave that 6 in the tens place, right? So I'm going to use my 4. My 4 tells me what should happen to the 6. In this case, we're going to round down, and we're going to round it to 6D. Okay? It's only got 1 significant digit because it's got a non-zero and a trailing 0. Remember, a trailing 0 is never significant. So now I have the right number of significant digits in my answer. Let's look at this example. I have 1.3 times 1.05. The first number, 1.3, has 1 non-zero, 2 non-zeros. That's 2 significant digits. 1.05 has a non-zero, an embedded 0, and another non-zero. That's 3 significant digits. When I put that number into the calculator, the answer I get is 1.365. Okay, but that has 4 significant digits, 4 non-zeros. And I can only have 2 significant digits. I'm going to start all the way at the left with my first significant digit and count 1, 2. So this is the place value to which I'm going to round. I'm going to round 1 point. The 6 tells me that I need to round it up to 4. I'm not going to put these placeholder zeros because I don't need them. If I put them, they would be trailing. I have a decimal, so they would be significant. That would mess me up. And if I leave them off, this is still 1 and 4/10. Just like this is 1 and 3/10. 1 and 3/10, 1 and 4/10. It stays in the same place value even without the extra zeros. Okay, let's look at this one. 380, whoops, that should be times 0.07. Okay, if I put that in the calculator, I'm going to get 266. Let's figure out how many significant digits I need. 380 has a non-zero, and a trailing zero but no decimal. That means that zero is not significant. I only have 2 significant digits. Here I've got a leading zero, which is not significant, a leading zero, which is not significant, and a non-zero. I have 1 significant digit. So I'm going to count over here. 1. That's the place value to which I'm going to round. I'm going to round 200. It's in the hundreds place, so I need to leave it there. The 6 tells me I'm going to round it up to 300. That's my final answer, 300. Let's do one more. Now I've got 1,073 times 0.70. If I put that in the calculator, I get 751.1. Let's look at my significant digits. Non-zero, embedded zero, non-zero, non-zero. That gives me 4 significant digits. Leading zero, that's not significant. Non-zero, this is a trailing zero, and since I have this decimal, it is significant. So that gives me 2 significant digits. How many significant digits should my answer have? Should have 2. 1, 2. I need to leave that in the tens place. The 1 tells me that I can round down. I'm going to round to 750. Okay? Please note that this does not tell you how many digits are in your answer, only how many digits are significant, right? But everything needs to stay in the same place value that it started. The 7 has to stay in the hundreds, the 5 has to stay in the tens, and we need something in the ones place. Since we need something that's not significant, we're going to put a 0. There's no decimal. That makes this a non-significant 0. And I only have 2 significant digits, which is what I need. Right? Okay, so let's review our rules. Our rules tell us that first we count the sig figs, or the significant digits. You'll see it written either way, sig figs, sig digs, in the numbers in the problem. Right? So that's the numbers that we are given. And then we make our answer have the same number of significant digits as the number from the problem with the fewest. The thing that students get most tripped up on here is actually not this rule. It's the rounding. So when you are rounding, please, please, please make sure that you are leaving the numbers in the right place value. Okay? Don't change your 700 to a 70. That is nowhere close. It's not a rounding then. It's not an estimate. That's far, far off from the real answer. Okay? You may want to write yourself a note. Whoops, what have I done? You may want to write yourself a note here that the thing you need to watch out for in all this is the rounding.